Hello viewers, in today's session we are going to discuss an important limit, right? And here in this class we are going to evaluate this limit, that is limit x tends to 1 minus. Here the negative sign shows that we have to find the left hand limit of this function when x approaches to 1, right? And the function is signum of x plus 1 divided by mod of 1 minus x plus the square of the greatest integer of x plus 1, right? So here we can see that three important functions in mathematics, that is the signum function, the mod function, and the greatest integer function are involved in this limit, right? So we'll evaluate this limit by taking the fundamental concepts, that is the definition of signum function, mod function, and the greatest integer function. So let us start. So since we have to find out the left hand limit of this function when x approaches to 1, right? So let us take a point in the left neighborhood of x is equal to 1. So this point may be taken as 1 minus h, and we are approaching from the left of x is equal to 1 towards x is equal to 1, right? And this point is 1 minus h, where h is a positive quantity, right? So h is positive quantity and it is infinitesimally very small. So when x approaches to 1, then h also approaches to 0, right? H is infinitesimally very small. So now we can write this limit. Let us call this limit as L. So L can be written in terms of h as limit h tends to 0, because when x tends to 1, then h tends to 0. So here we have signum, and signum function of x plus 1, x is 1 minus h. So here we have 1 minus h plus 1. In the denominator we have mod 1 minus 1 minus h, and here we have 1 minus h, the greatest integer function, and here we have plus 1. This is a square, right? So let us simplify it. So we have limit h tends to 0. This is signum function, and here we have 1 plus 1, 2 minus h, right? And here we have mod of c. This expression is 1 minus 1 plus h. So this is simply mod of h. So here we have mod of h, and here 1 plus 1 is 2. So we have 2 minus h square, the greatest integer function 2 minus h square, right? So now to move further, let us make use of the definition of signum function. So now signum of say p is defined like this. Signum of p is plus 1 whenever p is positive. Signum of p is 0 whenever p is equal to 0, and signum of p is minus 1 whenever p is less than 0, right? Now see, here we have 2 minus h, and 2 minus h is always greater than 0, because h is a very small quantity, that is infinitesimally very small, and moreover h lies between 0 and 1. So when h lies between 0 and 1, that is h is less than 1, then 2 minus h is always positive, right? So it implies that we can now use this definition of signum function, that is signum of p is positive 1 when p is greater than 0. So here p is 2 minus h, and 2 minus h is positive. So signum of 2 minus h may be taken as plus 1, right? And let us now consider this greatest integer function. Now see, 2 minus h, since h is a very small quantity, and when we subtract h from 2, then 2 minus h is slightly less than 2, but it is greater than 1, right? So we can easily conclude from this inequality that 2 minus h it lies between 1 and 2. So the greatest integer of 2 minus h is equal to 1, right? This number. So 2 minus h lies between 1 and 2. So the greatest integer of 2 minus h should be equal to 1. So here we can write 1, and here also we have 1. So now this limit assumes the form, that is the limit h tends to 0, and here we have this term that is plus 1, and in the denominator we have mod of h, and mod of h may be taken as h. So here we have h, and here we have greatest integer of 2 minus h is equal to 1. So here we have simply 1 square, right? So now we can take h is equal to 0 over here. So we have 1 over 0 plus 1, that is equal to 1 over 1 is equal to 1, right? So here's the value of this limit is equal to 1.